I am recording now. So my name is Gary King. I'm going to be covering MVC and Application Controller for Group 4. So, the Model View Controller is a pattern designed to separate applications into three components. You've got the model, the view, and the controller. The model part is the data that the user is going to work with. That's usually where people would typically call it like the back end. It's the thing that's really the workhorse that's going to be doing the work. The view is the user interface. It's the pretty thing that people tend to see, although sometimes a view can be as simple as like a command line interface or a terminal interface. That's probably going to be the example. That's the example I'm going to show is something very simple. I'm not going overly complicated. And then the controller acts as a bridge really between the view and the model. It takes the user input and then gets data from the model or does things according to what the user says with model data. And so that's what all those do. The model is, of course, where the data objects, database functions, that's where that all really resides, is what the controller will interact with as the user needs per their input. Here's an example of like an MVC. You could have the big gray cylinder be like a shared database, and you would have people running applications. The applications would be like your view, and the blue layer would be like the controller going between the two. View, again, simply user interface, like we talked about earlier, can be simple terminal, can be a graphical user interface like Windows. View is what gives the user that interaction. And it can be one of the most important aspects of the whole program, depending on who your customers are, or who your end users are going to be. If the priority for them is placed on how the interface looks, then you're probably going to spend more time on the user interface than any other part. If you're working with engineers, usually they don't care so much about the user interface and they want the back end to be powerful and do things. And so I find with a lot of those engineer type programs, you get a basic like terminal interface, but it does a lot with data. And then here's some examples. Left side would be a terminal interface. Right side would be a GUI user interface. The controller connects the view and the model. It's the thing that's going to pull data from the model. The user requests it through the view. And in the example I'm going to show you that I built, it's mostly like getter and setter functions. Get this, set this, and that's what it's going to do. It handles the business logic and processing. And I put this picture of a controller as an example. And at first I thought, you know, like a gamepad controller for like an Xbox, Nintendo game system, or PlayStation, wouldn't it be a good example of a controller? But I thought more about it, and I'm like, really the UI for any of those is what you see on the screen. And the controller really is the go-between between that user interface, which you see on the screen, and the model, the game that you're trying to play. So I thought it was actually a really good example. So now I want to switch over a bit and talk about application controller, how it's very similar in a lot of ways to an MVC. Obviously, we're talking about an application controller. That controller part of the MVC is very much part of this philosophy and design, but it does have some key differences. It's a more advanced version of the MVC, I guess you could say, in a way. It's definitely built for larger scale applications, things that are going to be handling a lot more people. It's not like, for example, a game for like Xbox or something where it's meant to be played by one person at a time or something like that. So the scope is really limited. No, these are meant for like internet-based applications that are going to have hundreds or thousands of users. It's got a central controller, which is going to delegate to different clients, and it's going to resolve maps, and it's going to invoke and resolve targets. So here's an example of what a application controller would look like. You might have 3 different users, just as like a small example here. You're each going to request a view, and all those requests are going to go to the same controller. It's going to go through some steps, get some data from the model, manipulate the data, provide it to the users. And they may get several screens. They'll be looking at different things on there. The application controller security practices. When I was reading about application controllers, one of the big things they said was a difference was how it handled security. It's like a whole different philosophy on how you'd handle security, where the MVC is really focused on, I feel like, simplifying software design and usability. It doesn't focus so much on trying to secure data as much as it is about making it simply available. Application controller is much heavier on the security side. It's about ensuring the privacy of data and ensuring the security of that data between the applications that you're going to be working with. So the application controller is going to have things like completeness checks, controls to ensure records processing from initiation to completion. It's going to have validation checks, making sure that the valid data is only the valid data is provided when you give certain input or processes. So it's not giving you bad data, it's only good data and only what you're asking for. Identifications, it's going to have controls to ensure that, okay, you are the user asking for this data, I'm only providing you, that user, with your data. So it's like if it was a bank, banks would use this kind of stuff. They'd have an application controller that says, oh, you're Gary, I'm not going to give you Brian's bank information. I'm just going to give you Gary's bank information. Gary doesn't need to know what's in Brian's bank. Authentication, it's going to provide controls to the application to ensure that that person is authorized. That's authentication and authorization, ensuring that the application is approved by the business. Input controls, going to have same things like as view. On the view part of the model view controller, you're going to make sure that you have the ability to accept input from the end user. And forensics controls, just controls to ensure that everything is correct, the data, the inputs, the outputs, everything is 100% accurate. Application controller is going to control which applications are in your IT environment and what you add to it. That kind of philosophy of, you don't want to just have people randomly downloading software or stuff to add into applications. You want to control the whole experience. Anything is going to go through an approval process before it's added. You're going to automatically identify trusted software that has authorization to run. You're going to prevent all other unauthorized applications from running. So I see this, with almost all the new updates, both for Windows, Mac OS, both of those operating systems that aren't like Linux open source stuff. They're all implementing far greater controls as to where you get your applications from, by default at least, where they really want to limit you to their application stores so they can control the experience and make sure that you're not getting software that hasn't been vetted. You're going to eliminate unknown and unwanted applications, reduce your risks and costs associated with malware, improve your overall network stability, identify all applications within the endpoint, protects against, and that's going to help protect against exploits and unpatched OS vulnerabilities and third-party vulnerabilities. So here's a sequence diagram of what the application controller would be like. You'd have like a client. It could be, say, all of us go to BYUI, so we all have access to Office 365. That would be a good example. You have like an Office 365 client interface. You say, I want to open this shared Word document that's shared with group 4 here. That request is going to go to the application controller. It's going to go to the mapper of the database, say, hey, get me this target. The mapper is going to say, okay, resolve that target. And then the mapper is going to say, okay, create that shared document for this group, and then invoke that target to dispatch it, display it to the users. And so that's the presentation. Any questions so far? Sorry, I went really quickly through that.
I appreciate going through it. So I think my big questions would be, uh, I wasn't exactly clear on the biggest differences between the MVC and the application controller. Are they like mutually exclusive, or would you say like a model view controller is more simple, whereas an application controller has higher functionality, or is it for different kinds of platforms?
Definitely the latter on the complexity bit. In my reading of it and from what I've seen in building it, I I would say they're not mutually exclusive. You could even start with like an MVC
Mhm.
and build that application up to an application controller type application.
Okay.
And you could kind of go the other way around. It just they're both philosophies that I don't, and that's I think the reason that they put them together kind of in that list is in the list of topics is
Mhm.
they're very similar. They have a lot of overlap. There
Right.
are some differences,
Okay.
but there's a big, large gray area, I would say.
Right. So you would say that maybe application controllers are like, I know that the MVC is supposed to help make static pages into dynamic pages, but then you would say like the application controller makes everything even more dynamic because it adds a lot more functionality.
Right. Everything's more dynamic, yeah. And it's also, I would say it's definitely a scalability thing. MVC, like pure MVC programs really aren't designed to handle a lot of different users at the same time, get and like making sure that each user gets dished out specific like individualized data.
Gotcha.
That's yeah. But
And
an
that's what makes
application
it
controller, that's what it's designed for, that kind of philosophy.
gotcha. I also really, really liked your analogy of a game controller as a controller for the MVC architecture. I think that works really well.
Yeah. I'll admit it's definitely when I went back and forth on. I was like, I want to use a gamepad controller because I'm like, we're gonna see it and go, oh yeah, we all know what that is and how that works. But then I was like, oh, but it's not really. But it is. It really
Yeah,
is.
it sounds
Can,
like it.
can I get some clarification a little bit on the application controller?
Yeah.
Let's go to slide 10 there. So that looks good. That part of the application controller, that makes sense. It's basically, it helps control the views that are seen by the clients to the main model, correct?
Right.
But then when you scroll down, you said it was used for security processes and for controlling what applications are allowed on the domain or in your network environment. That sounds like a totally different thing.
Yeah, it does. And so that was one of the things when I was looking into it. It's to me, it sounds like as far as we're concerned in development, it's almost like there's two philosophies that go by the same name.
There are, yeah. Because
Yeah.
I've seen the second one, and I've had to work with that at work actually.
Right.
Where that is something that's usually built into the Microsoft system admin suite, where we were
Right.
able to use pings and because they're all in the same domain controller or they're all on the same domain, you were able to control and push applications to individual clients. I think that's might be outside the spectrum of what we're trying to do.
That's probably right. Yeah. I mean, for this class where we're focused on development,
Right.
really this part. I think it's good to also know this part, and that's the part I was unsure about. I was like, do we need to cover it? But I thought I'd include it just in case. But yeah, that's really, and I didn't do a good job of separating out. That's like there is those two sides to the application controller. Well, or really two different. There's like that IT.
Yeah, two theories of it.
Philosophy, yeah, and then there's like the developer philosophy of it.
Do any of you guys remember? I remember we talked briefly about that utility when we took the Microsoft Server class. There was a name for that. It wasn't Active Directory. There was a utility that they used to use to push software. I can't remember the name of it.
Oh, that's
I'm taking
right.
that class right now, but if it was something that was covered later, I probably haven't gotten that yet.
Yeah, it was called, I remember, Brian, I remember now what you're talking about, and I know we had to configure it as like part of the last lab.
Yep, I just can't remember the name of it.
Oh, yeah.
And I remember we used to use it at work all the time to push things, and we used to like you said in the PowerPoint, we would control what updates get pushed and what software people are allowed. And I absolutely agree. We didn't want people having the ability to just go install whatever the heck they wanted without it being vetted first, you know. And make
I
sure it was
know.
safe.
Yeah, I know. I'm right now I'm working as a NetSuite ERP admin where I'm working. And so I'm not like a system admin working with the Microsoft side of things, but I do talk to those guys a lot because I've been in their shoes.
Mhm.
And I know it's one of the things that continues to frustrate them, just the way our company chooses to like do things. And they're like, certain users will come and say, I need this. It's like, well, why? We're trying to keep our system secure and locked down. And they're like, well, I just need it to do this thing because it's the only program I know how to use to do this. And they'll bring it all the way up to the executives and stuff. And then the executives are going to be like, well, just let them do it then. And it's so frustrating for them. It's like, why not just open up the floodgates then, right?
Exactly. Yeah. Because the execs don't know, but they'll push it.
Yeah, they'll be like, this person needs to do their job. Get it to them. Like, well, are you thinking about security at all? Like, don't we want to? No, don't really care. Haven't had a problem yet, so not worried about it. So,
Yeah, that's what I hate it when we get execs in control of that because they don't have a clue.
yeah.
I think a big part of the issue too is that like the people who are pushing to get the software added are like, oh, and pushing and pushing and pushing, and then the developer person only really gets brought in at the point where the executive has already made up their mind and they're like, oh, just make it happen already. And the developer's like, why didn't anyone consult me about this? I could have told you immediately that this was a bad idea.
Oh yeah. And then on top of that, when it's a licensed bit of software that they're demanding that everyone in their team has, it's like you do realize that each license costs like $2,000, right?
Oh,
Exactly.
yeah.
And your entire team having a copy of that is going to cost the company thousands of dollars. You realize that, right?
Well, that's the thing that needs
Just
to
make
be
it happen. They say they need it.
attention immediately. Like, oh, by the way, that thing that the guy just mentioned, that's going to cost about $10,000.
Yeah, exactly. It's like you guys have no clue what you're doing. That's why you're supposed to come to us for this because we are the gatekeepers to keep that kind of crap from going crazy.
Oh, exactly.
Something. Can you go back to slide 10?
Yeah.
We had where I was working. That looks exactly like the model kind of that we had for this giant program called QuickLinks. It was a massive database program because I worked for an insurance company. And they were offshoot of Regions Blue Shield, and they had this giant program called QuickLinks. It was all based on this massive SQL database that was basically it was just like this model link. It was on a larger scale. It was so crazy. We had like one or two main servers that held just like see the model box that you down there. That was the database. A couple servers held that were failover servers. Then your controller section, we had 6 servers that were just application control servers. And what they would do is just like you show here, people would log in to their clients. They'd have the QuickLinks clients package on their individual machines. And that would then jump over and automatically load balance across those 7 servers and decide which one to go to based on load. And it would then make the queries down to the database for the individual users. It was really amazing how it worked.
Wow.
Yeah,
That's
it was
cool.
so cool. And then on top of that, what they would do then, because the place I worked, they're online 24/7. They had to be up all the time. So what we had were we had 3 remote desktop servers that would have tons of people on, and each user on that remote desktop server would have a copy of QuickLinks, and then they'd be going in as well. So when we were here in the United States running, we had our whole team of people here in the United States in Bellevue, Washington, doing stuff. Then once we all logged out, the servers stayed online, and we would go in and we'd have to kick people when they didn't log out properly, you know, if they just closed their terminal window and didn't properly log out. Then we had people in Trizeto, India, a whole slew of people in a center over there that would log in. And so it was crazy. I'd come in the morning, I'd see all these people with crazy Indian names still logged in before they were logging out. And these servers, it was amazing. I'd have to come in the morning and make sure that every single one of those application servers was still running.
Dang.
Because sometimes overnight, because they had to do updates or backups of the SQL database every night. So the system would kind of shut down at 11 o'clock, right in between when India would come on and right after we had logged off at like, everyone at Bellevue had logged off at like 10 o'clock. So it gave it like a small window where the whole system was shut down momentarily, run backups and update the backups with the new SQL data that was just put in that day. And then it would come back online. And sometimes when it would come back online, one or two of those application servers wouldn't kick on. And so I'd have to go in and kick those individual servers back online sometimes when they didn't want to come up properly.
That's crazy.
But yeah, it was nuts. It was just because when I was seeing your application pattern right there, it looks exactly like that system. It's just crazy, only on a much bigger scale with server clusters and everything, because it was all virtualized as well in a massive ESXi VM box. They were all virtual machines, every single one of them.
Wow.
Yeah, it was so cool.
That is
Yeah,
cool.
it sounds amazing.
It was so awesome because they had they spent, I'm trying to remember, my boss would tell me everything. He was like, we spent like $5 million on the server, and they had one in-house, and then they had another one off-site in Yakima or somewhere that way. So it was in a different geological area in case something happened in Seattle area. Our system wouldn't get messed up, and then they had to load balance all the way to Yakima. It was so cool. And so we were constantly having to, because it was initially just in Bellevue and then Tukwila, but that's not very far away. So they're like, yeah, we need to move this a longer ways away so in case something happens.
Right.
So we had to move everything all the way from Tukwila to Yakima or something like that. And it was this massive server, and it had an immense amount of storage, so much RAM. It was crazy, this machine. It was incredible.
Oh,
But
that's
it
really
was
cool.
virtualizing all of it on this one machine. And then when we went to the data center in Yakima, the way they kept power running so that you would never have a power loss, even if power died, they had this massive flywheel. And I mean massive flywheel. And this thing's spinning all the time. And if power, and it's creating your energy. That's what was being used to create energy to keep the servers running, was the rotation of this massive flywheel. And if power shut down, the flywheel, because of its weight, would keep spinning, keep generating electricity. So even if there was no power at the location, at the data center, your servers stayed up. And it could keep rotating and generate electricity for like hours on end. And that's how they powered these massive data center in Yakima, this massive flywheel. It was so cool.
It's hard to believe something like a giant like kinetic energy could power a big machine like that.
Isn't it crazy? Isn't it cool?
Yeah,
I mean, when I say a massive flywheel, I mean a massive
You're talking like
flywheel.
stories tall, that kind of thing, or
They didn't have it upright. They had it laying down.
oh, gotcha.
And it was just always spinning. It had these motors just keeping it spinning. And then if power would fail, that motor would die, of course, but the weight in the flywheel would keep it going and keep the electricity running. It was so awesome.
Yeah, seriously.
I'm like, that's brilliant. I never thought of that.
I was just gonna say that's brilliant engineering.
I know. I just couldn't believe when I saw it. I was like, that's really cool. I was so glad I got to go there and or see this kind of stuff. I'm like, this is amazing, the stuff that they do, because the Tukwila data center didn't have anything cool like that. It was just a basic generator system with batteries, but the one over in Yakima was way intense. And they even had like a lot of companies would go there and they'd have giant server banks there where you'd put your server in, and a whole bunch of other companies had theirs. You would rent that space. And so they were controlling tons of people's data at this one place. It was so awesome. So they had to keep everything up and running.
Yeah, I can imagine. You can't get any kind of outages on that.
Exactly. It was so cool though. I'll never forget. I was like, that's amazing.
I love seeing those kinds of mechanical marvels.
I know.
Just like,
It was so
that's-
awesome.
I can't believe it.
But anyway, so when I saw your application model there, I'm like, that's just like, I've seen that. It works. It allows multiple users to access the same thing. And then whenever, for example, one of the teams would be making queries to the database, it would go through the application controller and it would send the changes needed to the SQL database for the user.
Awesome.
And like you said, it also allowed for security controls. So people from certain teams were only allowed certain parts allowed to access certain parts of the database where other people were allowed certain other parts, because we had individual logins that they had to use. That was, we had to create the user account for the Windows user, but then we also had to create the user account for the quick links, which also had a separate section where we had to also create. It was crazy. It was based on a Linux system that they transplanted into Windows, because it was originally all Linux based.
Right.
So we had to create the GUI login. There was 2 logins just for quick links. There was the GUI login, which was for the application directly. And then there was the database login to the SQL database that we had to create as well for them. And that's where we had to set all the user privileges and everything, and it would cross-check them to make sure they worked and that they were allowed access to things. It was super complicated.
That's a lot of administration.
Yeah.
Nice.
Every time we had to create one user, it was like a nightmare, especially if they had special privileges, because we could, of course, create template accounts. But if they
Right.
wanted something outside of the template accounts, then we had to actually log into, like you said, the engineering terminal window, and we had to know what these terminal commands meant, and it was crazy.
Yeah,
We had people that had been working there for 20 plus years, and they were the only ones who knew how to use the software, and they knew what every single abbreviation meant. But me coming in, I was like, I have no idea what access I'm granting them. I just know it says to give them SW, QW, well, whatever. I had no clue what any of that meant though. But it was cool. It was an amazing experience getting to work there.
That sounds
That's
way
really cool.
All right. I gotta say, I love hearing your stories about the places you've worked at.
Yeah, absolutely. That was way cool.
Let me
Heck,
show
I haven't
you
even told you about when I worked at FEMA.
Man.
Wow, sounds good.
At the Nike missile site. That place
Oh,
was so
geez.
awesome. The Nike missile place in Bothell on Nike Hill. I actually found the silo. I went and hunted around one day and found it.
Nice.
I know, it was so cool.
All right. So, do you guys want to look at basically some short examples I built?
Oh yeah.
Yeah, that sounds good.
This? Okay. So, hold up. So, this is, let's see, there we go. So, this student class is going to work as the model here. So, I'll start with the model part of the model view controller. It's going to hold some values like a name, a roll number, just really simple here. Then the view here is going to print out some information for us in a terminal-based, view here, so that you can just see some information: student's name, the roll number. Then the controller here is basically just going to call some methods. It's going to go to that model and say, give me the name, give me the roll number, and it's going to get and set some values, which it's going to send to the view to display when it's printing that out.
Perfect.
So really simple here. Let's see, there we go. Oh wait, nope, that's not displaying the right thing. So I was having some trouble trying to get it uploaded to, what was it, GitHub. So here we go. I need to come down here. I think run it as part of that. There we go. So this will give you an example of what it looks like. It's going to say student. I told it put in Gary, give me a roll number of 1, and I put it in twice.
Okay.
So there you go.
Perfect.
It's coming up twice. Any questions about that?
Oh, that looks good.
No, it looks really good.
It's very simple. And then I'm just going to close these so I don't confuse them with the application controller I built. I built that to be separate. But so the application controller really has one main sort of overarching class, that application controller class I built. It's going to have a few methods. It's going to check for if the user's authenticated. And then it's going to print out that method and return true. In this case, I'm not really doing authentication here. I'm just saying everyone's approved, but yeah, it could do that. And then it's going to tell you printed out this request so that you can track what requests are being made, and it'll let you know as part of displaying that. And then it's this dispatch request that's going to go out and call this dispatch class, and this is going to kind of tell it which view or what thing you're getting. So in this example, I built 3 pages, and those 3 pages are just, just kind of like, hey, this is the first page, second page, third page, just to let you know it's pulling from different classes and views. And this one, I just told it to go out and get these requests. So this dispatch request is first going to check if it equals that case, show it. If not, run the second case. If not, show that third case. So basically what it's going to do is just show us all 3 and not show it multiple times.
Okay.
And then this testing class is basically just a main class to tell it to run in the application controller. So we'll go ahead and run it now. And you can see page request, and then obviously the user's authenticated because I'm really not checking authentication, but it's doing that. And printing out a message. Any questions about that?
That looks good to me.
Yeah, it looks awesome. Very good work, my friend.
Yeah, way good.
Yeah, been trying to keep it really simple.
I feel you did a good job.
Awesome. Thank you, guys. I'm going to stop the recording here.
Yeah, go ahead.
Covered everything. And then